So hi, I'm Deb, and I'm here to talk about research accountability in machine learning. So at this point, a lot of these headlines are becoming more and more familiar, where we see issues of bias and sort of inappropriate deployments of machine learning models as they make their way into the real world, and especially begin to get integrated into products that are deployed widely. And I think the paradigm through which a lot of, at least machine learning researchers have been seeing these issues has been very much in this sort of over-the-wall engineering framing from sort of traditional engineering fields, where people see themselves doing the research and then throwing that research over a wall, where an engineering team will take that research and try to operationalize it into a product, and that being thrown over a wall, and that to impact a downstream user. When people read these headlines, they often think, oh, well, those are issues of machine learning products. Those are issues of products that have been released in the world and deployed. So these are actually engineering problems. Those that are building these products are the ones causing a lot of the problems that impact the affected user, because they're the ones throwing it over the wall to the user. And a lot of researchers feel really good about this because they see themselves as being on the other side of the wall. So they say, well, my research is not impacting the user. My decisions are not impacting the user because I'm all the way at the beginning of this process. I'm multiple degrees removed. And so I am safe from having to think about some of the issues that are impacting that downstream user. This is an engineering problem. And that framing isn't something that I made up in sort of response to NeurIP's decision to include sort of a broader impact statement and try to integrate the, some level of ethical consideration as part of their paper review process. A lot of the response from the research community was an active questioning of whether ethical considerations and broader impacts was part of our responsibility as machine learning researchers. There's some kind of like large voices in the field that brought up these issues of, maybe this is not something that machine learning researchers should be thinking of, but something that machine learning engineers should be thinking of. And that came up multiple times. Also, another kind of interesting concern that was raised was that, societal impacts is a whole field of, concerns and discussions, and maybe machine learning researchers are just not qualified to be thinking about this, and so it's not their responsibility. And then the other side of that dialogue were people that were raising up, very serious issues that had arisen as the result of the publication of machine learning research papers. One paper that caused a lot of stir was, a voice-to-face translation model that was seen as sort of potentially harmful for trans individuals, for example. There was a lot of sort of predictive policing technologies that people were really questioning as to why that kind of research direction was being pursued and actively funded in the research community. And then also, a very kind of notorious case of Microsoft AI Research had worked on a project for text generation of, automatic comments generation based off of an input article, and people seeing that as, an engine for misinformation. And so research that maybe shouldn't have been done or should have been questioned and approached differently. So, since about 2018, there's been this push for reflecting on negative impacts and reflecting on ethics as part of the peer review process. And finally, in 2020, NeurIP initiated and piloted a process for integrating societal impact and ethical reflections, such as financial conflicts of interest, as part of their process for peer review. My initiation into this conversation was I was a co-organizer of a workshop that happened in 2020 on navigating broader impacts of AI research. And at that workshop, which was the year that NeurIP was piloting their sort of first foray into ethics review, we brought together a bunch of experts from a variety of fields to have this conversation about what are the ethical questions with respect to the execution and development of AI research, and not deployment, but discussing specifically the context of the harms that arise as part of the research process and the research publication process. So first, I just want to go over what happened at NeurIPS and what ended up happening following that workshop, but then also sort of in consequence to a lot of the external events that happened at the same time. So at NeurIPS, there's been sort of 3 years of exploring the ethics review process. And because of my participation in that workshop, I kind of got folded into this whole conversation, and I ended up being ethics review chair for with Sammy Bengio in 2021. And now I'm one of 4 ethics review chairs in 2022. But in 2020, Yasin Gabriel was the ethics review chair, and he sort of piloted this conversation at NeurIPS. His work was to really introduce a separate, the requirement to establish a separate broader impact section to all papers. So all papers that were submitted to NeurIPS that year had to include a broader impact statement. If they didn't, they would be desk rejected. And then as part of that process, technical reviewers could flag papers that they thought were potentially harmful. And there was like a very minor ethics review process for the flagged papers. It was like just a couple dozen papers were flagged, and Yasin manually filtered through them and assigned them to ethical reviewers. And then in 2021, we realized that the broader impact, the separate section for broader impacts wasn't necessary. And so a paper checklist was introduced instead, where as part of the process for submission, all papers had to include a checklist, which included ethical considerations, but also other considerations around reproducibility, research integrity, et cetera. So the ethics reviews would have to look through over the entire paper to identify what the issues could potentially be. And the goal of 2021 was really to scale things up. There's around 9,000 plus papers submitted to NeurIPS every year, and we wanted a process that we could, that could be less labor intensive and could be sort of institutionalized. And the other focus of 2021 was making the ethics review process interdisciplinary. So bringing in experts with legal backgrounds or actual sort of scientific ethics backgrounds and integrating them into the ethics review process. So it wasn't just computer scientists looking at other computer scientists. I think that happened pretty smoothly in 2021. So in 2022, the focus has just been, formalizing and stabilizing the process, and then also releasing sort of some formal guidelines. So the ethics review guidelines sort of being solidified, and then also the ethics code of conduct. Oops, sorry. And so, yeah, out of that process, there's a couple artifacts. So if you're interested in sort of learning more about what happened at NeurIPS, I point you towards these resources. Specifically, we had a panel to discuss it at that conference. We wrote a pretty thorough blog post kind of discussing everything that happened. And then I think the code of conduct does a really great job outlining all the major areas that we identified. There's also a paper I worked on with other co-organizers of that initial workshop called Disentangling the Components of Ethical Research in Machine Learning, where we break down the area of issues. And I think that that's a pretty comprehensive overview of that discussion. So, since the 2022 process is not done yet, I want to kind of contextualize this conversation with a reflection of what had happened during the ethics review process in 2021, and kind of use that as an illustration of what this ethics review process looks like for a machine learning conference. Since we did this process, we've had, a lot of input from other communities, ICML, ICLR, really considering ethics review processes. A lot of the computer vision conferences like EECV and CVPR, trying to think about how to integrate ethics into their process. And then a lot of work from the NLP space, which really initiated a lot of this conversation. So ACL, NACL, those conferences also beginning to sort of take inspiration and cite the work that we've been doing, but also we took a lot of inspiration from each other. So this is a process that's specific to NeurIPS, but ended up sort of impacting and influencing other machine learning conferences. And we were impacted and inspired by those conferences as well when designing this process. But I think it's a good representative set of experiences of what it's like to do an ethics review at a major sort of machine learning conference. So for 2021, there are about 260 papers flagged, again, out of about 9,000 submissions. These are really large conferences. The community is quite big. And so each paper that was flagged by a sort of quote unquote technical reviewer, or a reviewer that was sort of assessing the technical quality of the work. And then every flagged paper was given to 2 ethics reviewers with the sort of relevant expertise to provide context to the ethical issue that was raised. And then so we ended up with about 450 submitted ethics reviews, and about 140 of those reviews it resulted in sort of dialogue and responses with the authors and back and forth with the authors. So 8 papers were conditionally accepted on the basis of ethical reasons, meaning that we would not accept them until they satisfied certain conditions laid out by the ethical reviewers in order to sort of be seen as ethically sound. And then 1 paper was rejected on ethical grounds that year. And the whole process was conducted by 2 ethical review chairs, me and Sammy Bengio, in addition to about 100 ethics reviewers. So, who were these ethics reviewers? Here's sort of a breakdown of the different expertise level, like expertise areas of the ethics reviewers, and also a breakdown of the issues that these papers were flagged with. So, you can sort of see a lot of privacy and security issues were flagged, a lot of inappropriate applications and sort of broader impact issues were flagged. But a lot of our expertise, because we still did disproportionately have a lot of computer scientists participating, a lot of the expertise of the ethical reviewers that we recruited were in the sort of like discrimination, bias, fairness concerns category, even though that wasn't necessarily the most highly flagged set of problems. Also, you'll notice we didn't necessarily have a lot. We only had about 13 ethical reviewers with a legal background, which made it a pretty heavy load because there were about about 30 papers flagged for that. So there was a little bit of imbalance between the type of expertise we had available to us through these ethical reviewers and the types of issues that we saw. But we did our best to try to match ethical reviewers to papers flagged for issues within their expertise so that they could speak in an informed manner about the problems that had been identified with the papers. And there were also a lot of false flags. So, for 61% of the flagged submissions, at least 1 ethical reviewer concluded that there was not actually an ethical issue. So a lot of the false positives, for example, were just papers that reviewers, like technical reviewers, did not like, so poorly presented, and they kind of framed that as an ethical question. And then also there was quite a bit of like plagiarism and code of conduct violations that we actually had determined to be out of scope of the ethics review process and to be handled separately by the program chairs. So that also kind of ended up being a large portion of the false positives that were flagged. And then in terms of false negatives that were flagged, a lot of papers made use of data sets that had already been depreciated by the creators of that data set for ethical reasons. So an example of this is Duke MCMC, where the data set was collected without the consent of those that were in the data set. The authors recognized this harm and retracted the data set from mainstream use, but people still created copies that they were making use of as part of their research projects. So we actually did sort of manual keyword searches for that data set to try to identify papers that were making use of that retracted data set. And that was not necessarily, whether or not it was flagged by the technical reviewer, we proactively looked for those papers as part of our process of identifying papers with potential ethical issues. And then similarly, there were papers that were on sensitive topics that we were already aware of. So for example, biometric data generation, so generating a face or voice, or surveillance. And we knew that there were probably ethical issues with these papers. So we had a keyword search related to those sort of key issues as well. And we were able to identify a bunch of papers through that process. And so in this paper we have on sort of disentangling research ethics, we create a taxonomy that ended up sort of being pretty fundamental to the framing of the code of ethics that NeurIPS is currently drafting, but really breaking down a lot of the identified problems into 3 categories. So one is, research integrity issues, where, you want to make sure that your research is saying what it is saying. So, reproducibility and replicability issues, articulating and communicating assumptions and limitations, presenting the data honestly. So we pulled that all under sort of research integrity. And then separate from that are harms that are associated with the research process. So these are harms that come about as you go through the research process. So as you develop the process and also execute the research project, there's harms that can happen as a result of that. And these are a lot of the harms that are identified traditionally through like an IRB process. So you think of ethical obligations to research participants and research subjects, the treatment of workers who contribute, consideration for process impacts to non-participants, management and use of assets, et cetera. And then finally, the sort of third category we're looking at were sort of these downstream consequences. So ethical questions that came as the result of, the implications of that research project. And this is really the sort of broader impact section that had existed in the 2020 iteration, but really looking at, the ethics of the research questions being explored in the problem formulations, reflecting on mitigation of possible downstream impacts, et cetera. So I can only really talk through some of these ideas through a concrete example. And because, it doesn't make sense to critique anyone other than myself here, I'm going to talk about a research project that I was a part of, and the ethical questions and considerations that we had not even realized as we were doing the research process that became clear afterwards. And I just want to use this as a way to just illustrate that even those that are quite careful and do pay a lot of attention to these issues can still fall into the trap of not being aware of the full scope of problems that can occur, and that becoming sort of a key liability for the machine learning research community as we progress. So the example I'm going to give is a project called Gender Shades. So with the Gender Shades project, pretty much the main contribution was this pilot parliaments benchmark. And you can see here that the creation of this benchmark was a huge divergence from the mainstream facial recognition benchmarks that had been available at the time. Those benchmarks were disproportionately male and lighter skinned, and the pilot parliaments benchmark was really balanced with respect to male, female, and darker, lighter representation. And here's just like an example of what that benchmark looks like. And so what was enabled by the creation of this benchmark was that Joy Bulamwini and Timnit, I was kind of involved peripherally at that point, and then I became more involved later on. We did these audits of commercial facial recognition products using the pilot parliaments benchmark. So we were able to identify that, Microsoft's commercial facial recognition product, for example, was only, 80% performant on the darker female subgroup compared to 100% performant on the lighter male subgroup. And these are called sort of algorithm audit studies. And this is, one really canonical example of one of those studies. So as a research process, there was a lot of attention that was paid towards ethical issues, but there's a lot of things that we learned after the release of these projects that revealed dimensions that are not typically considered as part of the machine learning research process. So here's kind of an overview of ethical considerations we had missed in the development of this project, and how much that reveals of the typical sort of oversight or ways that in which those engaging in the process overlook certain things. So, one thing that we hadn't really realized as we were working on this is the importance of picking an appropriate research topic. So, since then we've probably seen a lot of these, people complaining on Twitter about some of these like very sort of questionable research projects that sometimes make their way into publication. So, one example over here is a model that's meant to detect the deception of someone's walk. And then there's also, the automatic comment generation model, where it automatically generates comments depending on a news article, and that being obviously a very kind of high potential tool for misinformation. And the way that we saw that manifested with sort of our work in facial recognition auditing was that people were trying to do similar audits and follow up to our work to audit, products that were using the face to detect hireability or criminality. And it was a little bit of a strange situation because we realized that those tasks themselves are pseudoscientific and incomplete. And so the idea of auditing for bias of a tool, trying to predict hireability or criminality didn't make sense just because of the nature of that research topic, the inappropriateness of that research topic. And that's when we really recognized that there was a whole set of ethical questions around just the appropriateness of the research topic in question and being investigated. And we've seen that really play out over the last couple of years, people calling out all the ways in which people are using facial recognition to try to predict things that, really doesn't make sense to predict or to attempt to predict. So trying to use facial recognition to predict someone's sexuality or trustworthiness or political orientation or criminality. And that just being completely inappropriate as a topic discussion in the first place, just not because of just its unscientific nature, but also the potential for harm. And then another dimension to this is that there are certain research topics that are just more amenable to misuse and to being abused by certain actors. So, for example, facial recognition in general as a topic of research is just more liable to being misused by, for example, those in a position of power that might not necessarily use that technology responsibly. So the police or other sort of institutions of power. And then, for example, there's this sort of research paper that had happened attempting to differentiate between minority Chinese groups and majority Chinese, like the Han Chinese groups, and that obviously being potentially or easily weaponized by different governments or different institutions to target those minority groups. So this also includes the Chinese sort of Uyghur group, which is a little terrifying. So there are research topics that are also just more amenable to weaponization, abuse, and misuse, and that should also be called out and regulated. The other sort of thing that we learned post Gender Shades was, the importance of conflict of interest. So, Timnit Gebru is one of the authors of Gender Shades, and later on, she sort of worked on a project internally at Google that, got her into quite a bit of trouble, and she ended up getting fired for it. And it was a really striking moment because it revealed the fact that, within the company, there is some level of moderation in terms of what gets published and what gets put out. And so when we look at research papers coming from specific institutions, we actually have to contextualize what we're reading in the context of what is allowed to be presented and communicated by that institution or through that institution. So another really clear example of this happening concretely were these audit studies that were done on hiring products, algorithmic hiring products by Northeastern and by a consulting company called Orca. So Orca did an audit of a product called HireView, which uses, video footage and your response to these quizzes to determine if you're a good candidate for a job. And Orca was hired by HireView in order to do this study. And so as a result, HireView had a lot of control over the message and the scope of the audit that Orca did, and also restricted distribution of the study based off of who they wanted to share those conclusions with. And similarly, a group at Northeastern was hired by Pymetrics, which is a company that builds, a similar sort of algorithmic hiring tool based off of a series of surveys. And the researchers at Northeastern were hired by Pymetrics to execute the study. And so the publication of the paper was mediated by the Pymetrics team. And so again, the scope of the audit, the nature of the scrutiny, the level of scrutiny of the validation process, and also the degree to which their results were made public or available was controlled by the company that had paid to have the study done. So this question of researcher independence became a really big topic in the sort of algorithm audit space. And after our work with Gender Shades, especially when we audited Amazon's product later on, we kind of saw this come up in that space as well, where there were like the companies that were audited would take a lot of initiative to participate in the research conversation. So Amazon launched an entire NSF program on fairness. They added new features following the debate on, facial recognition and bias. But Microsoft also kind of made updates and changes to their product, but they also would organize these workshops. This is a workshop that that IBM, directly contributed to at CDPR in response to some of the Gender Shades work. And you can see that it's very specifically sort of targeting, influencing the research conversation on these topics. So that was an interesting and sort of alarming realization of sometimes these companies will actively participate in these projects in order to highlight or influence the dialogue on some of these issues that affect them. And then another example is, there's a paper that was looking at reproducing our studies and trying to calibrate or improve performance on some of these systems. And, the lead sort of authors or participants in that project were, funded by the CIA and had a history of participation in the CIA. So they had a very defensive position and interest in sort of supporting the use of facial recognition technology. So that again sort of revealed this issue of conflict of interest and how important it is to disclose funding, disclose actual affiliation in history when communicating about these issues. Another sort of issue is that of harmful methodological design. So, we, in the machine learning space, in order to label the data sets, there's reliance on this, invisible workforce, these ghost workers that will label these data sets, and thinking through the impacts of the research process on those workers, but also the process of data collection being very ad hoc, the availability of the internet and a lot of, physical surveillance apparatus, in addition to sort of digital surveillance apparatus like, cookies or scrapers or whatever, to collect as much information as possible for these models to be trained, reveals a lot of potential for harmful methodological impact. And, some of the definition of the categories involved in, even something as simple as defining race categories in machine learning, or gender categories in machine learning, or skin type and thinking through skin type, reveals some of the ways in which the decisions being made in the research design process has these downstream impacts on various populations. And we experienced that post gender shades as well. Some of the corporate responses included IBM's publication of, this diversity in faces data set, where they attempted to mitigate issues by creating a data set that was, as large and as diverse as possible and included as many faces as possible. However, the faces that they had included in that data set were from Flickr, and they didn't actively seek informed consent from those that had uploaded their images to Flickr, who had not uploaded their images thinking that it would be included as part of a facial recognition data set. So we would see all of these issues as people were trying to build larger data sets and diversify their data. They would fall into these traps of, overlooking consent and privacy. In some cases, so we had audited Face++, which is a Chinese company, another Chinese company, CloudWalk, also hoping to minimize the bias of their products, purchased a bunch of face data from the Zimbabwe government. So there was a lot of these interesting, strange interactions that we saw of, really needing to set ethical boundaries around how people were collecting data and making use of data and categorizing data. And a good example of someone that was a little bit more careful was Facebook actually released this causal conversations data set, where they hired a bunch of actors to, make various expressions and speak into the camera, and then they took screenshots of these actors. The whole thing was much more expensive than just scraping the internet for faces, but there was a process of consent and privacy, and there was also like a mediation around diversity and making sure that the data set itself was as rich as possible. So that and the goal of the data set was meant to be used for specifically evaluation. So there was a lot of details about this project that revealed that actually we could be a lot more thoughtful around data collection, data diversity, all of these questions during the research process and of how we develop these models and how we evaluate these models. And then finally there's there's also this issue of research integrity. Very inflammatory and provocative, they misrepresent really what the models are doing, and there are a lot of ethical concerns just connected to that. So the way that it showed up in our work was that the scope of the impact of our audits are actually quite specific to specific demographics and specific prediction tasks in a specific company. And in our follow-up work, we were very clear about making sure that we communicated that our audit results were scoped and it wasn't necessarily broadly applicable beyond what the claims of the initial papers were. So, for example, our benchmark is balanced with respect to, male and female representation, but something like age, the data set is quite biased with respect to age. So it would not be a good benchmark to evaluate the performance or the bias of these commercial facial recognition products on, the age of a particular subject. So yeah, there's things like that we needed to clarify around the limitations of our study. And we realized that was also a research ethics question of communicating honestly about the limitations and scope of your audit result, of your research results. And then finally, another kind of big lesson we learned was the importance of addressing and acknowledging legal issues. So this shows up in various ways in terms of legal compatibility, but also implications in terms of copyright. So for the pilot parliaments benchmark, these were images of public figures who were parliamentarians, and they were on, public online web pages. So they were just scraped from the internet of these parliamentarians. And I think that was sort of the best we could do, just given the scope of the paper and the reality of the fact that they're public figures. So a lot of other data sets, reliant on like celebrity faces, make a similar argument. However, even the idea of doing, these audit studies or discrimination studies, there have been companies pushing back with the Computer Fraud and Abuse Act saying you cannot, audit my commercial, application program interface product, API product, because part of my terms of use forbids the use of this technology in a particular way, or you can't scrape data from my platform in this particular way. So privacy and anti-hacking laws have been leveraged against a lot of people doing AI accountability work, and that revealed a dimension of legal challenges that had previously been just unaddressed or undiscussed. And it revealed also the importance of making sure that when we do any kind of study, we're aware of the legal landscape in which we're operating. So a path forward in terms of things that we can think about as a machine learning community. So one is the importance of informed consent and human subjects research. Data involves humans in a way that it always has. And especially when one is training models on humans and making decisions about humans using data, it's incredibly important to reflect on the reality of the fact that data science is human subject research. And so, as with any other human subject research, the importance of going through an IRB process is super integral to making sure that all the considerations of consent and privacy are adequately considered. And then going back to sort of some of the legal and data accountability issues, the community needs to have a conversation about the implications of fair use and copyright law as it relates to training data, as it relates to test data, thinking through collecting sensitive data such as, face data or biometric data, and the implications, the legal implications of that is something the community needs to do. So for example, the GitHub Copilot project, where they were like making use of, code bases on public code bases on GitHub, violating, potentially violating code licenses, thinking through face data and how that could violate sort of biometric protection laws, and then obviously reflecting on Creative Commons and some of these institutions and how they can kind of participate in that conversation. Disproportionately, there's been sort of this emphasis on data documentation and licensing as an approach as well to consider. And I think that that's a growing conversation because of the difficulty of enforcement, but it's definitely something the community needs to start thinking about and talking about more openly. So the idea of data sheets, model cards, data statements, the rail or data licenses, those are things that the community needs to start reflecting on how that can enforce a little bit of research accountability. And then finally, the ethics review process, like I had mentioned earlier, was really great at identifying issues that came up at the NERVS 2021 conference. And these are just some of the issues that we identified. So, a lack of sufficient reflection was 99% of the problem. A lot of people just hadn't thought through the ethical considerations involved in their work. The use of depreciated data sets, inappropriate communication, a lot of the things that we had learned through our process after releasing the Gender Shades audit, for example, other people were also learning through the ethics review process proactively, pre-publication of their projects. And that was really interesting and great to see. So these are all kind of challenges that the community has collectively acknowledged and realized. And the ethics review process did a really good job educating people and informing their next steps. So, it's become increasingly clear that, yes, there are definitely problems with how people build these systems and how they deploy them. But there's also a lot of problems in the research space as well, and the decisions that we make as researchers. And in fact, especially in the machine learning space, where a lot of the participants in the research process work at these tech companies and participate in these tech companies, it's become incredibly important to just recognize that there is no wall there and everyone is responsible and has responsibilities. Thank you.